Hello, everyone. I'm excited to welcome you to our first edition of Angular Spring Camp. I am Mateusz, and I have a pleasure of being your host for today's event. I represent Angular.love community, which is organizing this gathering. We are live streaming from our office in Warsaw. Please let us know in the comments from which city you are joining us. Angular Spring Camp is a free event, including a series of free meetups, specially created with love for all of the Angular enthusiasts and those who want to gain particular knowledge from the sessions. We are very delighted that so many people have already joined us. There is about 100 people with us, so it's really great score, and we are extremely happy. I have to mention that it wouldn't be possible without our sponsor, House of Angular. The House of Angular team specializes in consulting and code audits. If you need assistance with your existing project or want to start the new development the right way, don't hesitate to reach out to them. Before we kick things off, I would like to share some important information. First and foremost, today we have two exciting talks lined up, featuring Alain Chautard and Hahnekamp. Following each talk, we'll have the Q&A session. So don't hesitate to drop your question in the chat. All of the questions will be for sure asked. At our meetups, your voice matters most. And these meetups, all of that, what we create is create for the community. To help us make future events even better, please share your thoughts in our post-event survey. Provide us with your priceless feedback, which we can use to create and make our future events even better. Also, after the event, we would like to invite you for a small networking on the Google Meet, where we can talk about the talks, but also about the Angular in general. Thank you for being a part of our community. So with that all, let's dive to our first talk. Let me introduce Alain. Alain is recognized Google developer expert in web technologies, Angular, and Google Maps. He provides an Angular training project that helps developers improve their skills. He's here to share his expertise on all about the Angular signals and why they matter so much. Welcome, Alain.
Thank you. Welcome, everyone. Can you hear me?
Yes, I can hear you. Can you hear us?
Good.
Yeah.
Perfect.
So how are you doing?
I'm doing great, thank you. It's early morning for me here in California, and I see we have people from all around the world today, so that's great.
Yeah, it's already 180 people, so it's the best score we ever get probably. So we are extremely excited. And before we dive in, I would like to ask you some questions. So I know that you're with an Angular community for so many years, and would like to ask your opinion about recent changes, how you are feeling with these recent changes which frameworks undergo.
Yeah, I think the recent changes in Angular are super exciting because, we've been working with the framework for a while. At least I've been working with the framework for a while. And, people kept comparing Angular to other things. And they would say, oh, but, maybe React is easier, or X, Y, or Z is easier to learn and everything. With the modern Angular, that's not true anymore, right? Angular is becoming a lot easier to learn, a lot easier to get into. A lot of things make more sense. I think the syntax is getting simplified, and it seems like it's just the beginning, right? The Angular team is really trying to push this even further, and it's going to simplify the framework even more. So I think it's really the best time to be an Angular developer right now, because things are always improving, even maybe faster than ever before. And there's always new things to learn that make our framework more performant, faster, and easier to get into. So it's all good news.
Yeah, and just probably the first time we can feel the proud when we see these tables comparing the performance of the framework, and Angular is close to the very beginning, not the last one, the slowest one. So yeah, it's really great time to be in Angular community and be the Angular developer. I have one more question. If you can say us a little bit more about your Angular training project, what inspired you, and what this entire project is about.
Yeah, so Angular Training is my company. And so what I do is I teach Angular all around the world. And before the pandemic, I used to travel a lot. These days, it's more online. So I do live sessions online. I do video courses that are recorded and that people can, replay on their own online courses. YouTube, my own platform. Also blog a lot about Angular. I have a weekly newsletter. So really creating content that is as accessible and as free as possible, I would say.
Yeah.
So I try to put as much free stuff as possible out there so people can learn, no matter where they come from, no matter their circumstances, they have access to good quality content, which that's really what I've been focusing on for years now, and yeah, keep doing this.
Yeah, that's awesome. Thank you for your work for the community. And okay, without taking more time, the stage is yours, and we'll see you at the Q&A session. So I wish you good luck.
Perfect. Thank you. And so I'm going to share my slides, and I'll get things started. All right. So today we are going to talk about Angular signals and everything there is to know about Angular signals. So what I mean by this is that, signals have happened a few months ago, first as a developer preview, now as part of the framework. And the Angular team keeps adding new APIs to these signals. And it's really a very important turn in the direction that Angular is going. And so much so that I thought it's a good idea to do a talk and explain why Angular signals in the first place, why the Angular team added these features to the framework, how it's going to change Angular in the next few months. But even right now, if you get into them right now, you can really architect your apps completely differently and start using signals right away. And yeah, we'll see what are the impacts and the benefits in terms of performance, in terms of architecture, in terms of making your Angular apps easier to maintain as well, with a learning curve that's a lot easier to get into than ever before. So just quick intro. We already did some of that. My name is Alain, or just Al. I'm based in Sacramento, California. I'm a GDE in Angular and Google Maps. I started with AngularJS a long time ago, back in 2011, and I do consulting and training at angulartraining.com. And I've been speaking at conferences all around the world, all continents but Antarctica. And yeah, always happy to be here. And as part of what I do with Angular training, I mentioned I do consulting, I do training. We also have a certification program, which is entirely made by Google developer experts in Angular. So if you're looking for a way to showcase your skills for your employer, or you're looking a new job and you want to show that you're a good Angular developer, we have 3 different certifications from junior to expert. So you can check it out, and there's going to be a coupon code at the end of this talk, so you can get a lower price on these certifications and training courses. So with that said, why signals? So the Angular team started signals with Angular 16, and the idea is that signals are the Angular that you already know, with 3 new functions or 3 new reactive primitives that simplify your development and build faster apps by default. So the idea behind Signal is to make it easier to have reactivity everywhere, so that you write code that's reactive, meaning the user clicks on something, you get new data, and all of the components and services that are interested in that change react instantly. It simplifies change detection. It's more precise. And that's one of the things we're going to see in a few minutes. Signals are going to be a lot more precise about how to update our components. And they're also super lightweight. signals are about 2 kilobytes of code and really fast. There is no need for a dependency, no need for third-party code. It's all included, all part of the framework, and it's as simple as it gets. So if you use the default change detection strategy in Angular today, it kind of works like this, where this is a tree of components, and if you click on a button at the very bottom of our component hierarchy, then you have zone.js that's going to tell Angular, hey, something happened. And that something happened doesn't really tell what or where. And so Angular, by default, has no other choice but to check every single component of our hierarchy from top to bottom, right? That's a default change detection that we have in Angular right now. And it works, right? It works really well. It is performant. We use it every day, and we are quite happy with that. But the thing is, it could be better. And when we start having signals, the idea is that the hierarchy of our tree doesn't matter so much anymore. The fact that we have parent-child relationships, and historically we had that top-down approach to change detection, where you're supposed to pass data from one parent component to the child and have that data flow down really from top to bottom. With signals, this goes away, in the sense that when a component uses a signal and changes data of its signal, then all of the other components that use that data are going to be notified. So that's what I'm representing here, where component number 1 makes a change, it's going to impact component number 2, number 3, number 4, and it's not impacting the entire tree, just the components that use that data. And not only that, not only is it just the components that are interested in that change, it's going to be the views within those components that are interested in that change. So it's really a lot more precise than just refreshing the entire app. It's not going to only be these components that display the data, but just the views. And a view is a subset of an Angular template, if you will. So if you use a for loop like ng-for or ng-if, this creates a new view in the template, which means that if you have a component that has one ng-if that relies on a signal, and the signal changes, then Angular knows that it's only this little view around the ng-if that has to be updated, and not the rest of that component. So it's really more precise than ever before, and super pinpointed to the strict minimum of changes that we have to make to the DOM are going to happen thanks to these signals. So that's really a very big thing, and it could be the #1 reason to get into signals, really, because if you strive to improve performance and change detection using on push, for instance, and creating presentation components, and you can try as much as you want, or taking control of change detection kind of manually. You can do that, of course, but it's work. Whereas with signals, you get everything automatically, and you don't have to. The only thing you have to do is use signals, really. So, so the idea is to, other than performance and change detection improvements, several of the ideas behind signals are to simplify the approach on how to learn Angular. The concepts are as basic as possible. With signals, we only have 3 functions. And remember that if you use RxJS, last time I counted, has over 120 operators, right? So if you really want to know RxJS and Angular in depth, you would have to learn 120 operators. With signals, we have 3 functions. So kind of gives you a difference in terms of simplicity and the ease of access and getting into signals. So yeah, interoperability is always something that's important for Angular. Something I want to mention, and that was announced by the Angular team a few weeks back at NgConf is that Angular signals are actually used in YouTube right now. So YouTube is not built on Angular, but YouTube is using Angular signals everywhere. So that's a very big step, because you know that YouTube is a massive web application. You're probably using it right now to watch this talk. And the fact that YouTube is now using Angular signals under the hood is really a big vote of confidence toward the technology, and a proof that it really makes a difference and it's super performant. So signals are backwards compatible and interoperable with everything we have now, meaning that there are functions to convert signals back to observables if we want to. So how to use them? Let's get into the basics of signals. And I'm going to cover all of the APIs during this talk, including the latest. And the next talk is going to be about how to do state management with NgRx signals. So we mentioned there's three reactive primitives: signal, computed, and effect. These are the three functions that we have to know about. The first one, signal, easy enough. It's a function that you call, you pass a default value to it, and it creates a signal. And what this signal does is that it can notify any piece of code that's reading that value every time the value changes. So I have a quick demo here, because it's always good to look at some code. So very simple. It creates a signal with the value Angular, as you can see down here. And the idea is I have a button, and when we click on that button, I change the value of my signal. So to change the value of the signal, we have a set function on it. So I do name.setWorld to change the value of my signal to world. And then we have an expression here that just displays the value of the signal. So to read the value of a signal, we call it as a function, as a getter. And that's the basics of the API. Creating a signal with a default value, setting a new value to a signal, and displaying the current value of a signal. If you know this, you're good to go. You can start adopting signals right away. And of course, it works. So if I click on my button here, now it says hello world, because we changed the value of the signal to world. And you can see that I didn't need to change anything else in that component, didn't change the change detection, didn't change much of anything. All I did was import the signal function from Angular core, and that's it. So that's a basic signal. Now, in order to update a signal, we have two different options. The first one is set, which is the one I just showed you. You can use a set method to update the value. And if the value you're updating is derived from the current value, like a counter where you're going to increment something, then in that case, you want to use the update function. And the update function receives the current value and allows you to derive a new value for that. And again, perfect example for this is a counter. So here we have a signal with a value of 1. If we want to increment it later, we do signal.update current value, return current value plus 1. And so, yeah, now you know about how to create a signal, how to update it, and how to read its value. And that's, that can cover a lot of use cases already. And the API is already a lot simpler than dealing with, let's say, subjects or RxJS observables. The second function we have with signals is computed. And with computed, the idea is to derive a new value from a signal. So when you have a signal A that does something, And when the value of that signal A is updated, computed is going to react and create a new value out of that. So let's take a look at an example. So here we have a bunch of different signals. So I have two of them, a greeting, hello, and a name, which is set to Angular. So two different signals. And I'm combining these two signals into just one using computed. So computed creates a message out of the two signals by concatenating the greeting and the name and adding an exclamation mark. And that's it. That computed function is automatically going to derive a value when either greeting or name changes. So if greeting changes, computed gets a new value. If name changes, computed gets a new value. And we can check that because my component here, so right now it says hello Angular. That hello Angular comes from this message signal. So we can tell that it already has a value, getting the greeting from our greeting signal and getting the name from our name signal. And it computed that value, the concatenation, and displayed it. And now if I change any of these signals, so let's say I change the greeting to welcome by clicking that button, you see that my computed signal now says welcome Angular. So that's just happening. Computed automatically gets updated when any of these values change. So you can really see computed as a replacement for a lot of RxJS operators. You know, all of the things we tended to use like map, switch map, and all of these transformation, concatenation operators from RxJS, they all become computed, really, pretty much, which is a lot easier to learn. And yeah, anything you change in that function is going to be a trigger for the computed signal to update and get a new value. So it's really as easy as it gets. I really love computed. It's probably the biggest simplification to get from signals compared to RxJS operators, for sure. And so, yeah, I can change the text as well. So whether I change one signal or the other, you can see that it's all reactive. I click on these buttons, and it works. The interesting thing about this that I can mention as well is that with this code, even if we disabled Zone.js, it would still work. So those clicks would still make Angular re-render that component. And that's because the signals, when we set a new value, they automatically mark the component as, you know, dirty. So it has to be re-rendered again. So the signals do the work already of telling Angular this component needs to be rendered, which means that for that component, at least, we could get rid of Zone.js and it would work. And we'll see that it's really the direction towards which Angular is going. And we'll see what other APIs have been added recently to go fully in that direction. So that was computed. It's our function number 2. And the third one is effect. So effect is somewhat similar to computed, with the difference that it doesn't return a new value. So computed knows when a signal changes and creates a new value out of it. Effect does pretty much the same. It's going to get triggered when a dependency changes, when a signal changes, but it doesn't return a new value. It just does a background task and then completes, in a sense. So you can use that for many different scenarios in my example, all I did with effect is a console log. So I used effect to log whenever our message changes. So I log message change to this.message, which means if I show my console and I click on any of these buttons, you can see that everything gets logged to the console. And now you know all of the basics of Angular signals. See, we can cover all of that in like 10, 15 minutes. Whereas if I had to do the same with RxJS, it would take it would take closer to half a day to get to a point where we can be comfortable with all of these things. So that's really powerful. Signal, computed, effect, and the setup function to change the value. So one thing that is important to know about is that we have two types of signals, right? Some are writable and some are read-only. So when you create a signal with the signal function, this signal is a writable signal. You can change the value, you can set new values and everything. But if you want to expose it as a read-only version, let's say you create a signal in a service and you want to expose a read-only version of that signal, very similar to when you have an RxJS subject and you want to expose it as an observable, there's this as read-only function to do that. That's going to return a new signal that's read-only, so you can expose it and it's safe. The consumers cannot change the values anymore. And signals created with computed and effect are read-only. Meaning, of course, these ones are automatically updated based on the triggers and based on the other signals that they're consuming. So other than that, they're read-only because the logic to update is within those functions. And as a result, we cannot change that. We cannot mess with that. So what about RxJS? What does RxJS become in all of that? So in the past, we would do something like this, or maybe still in the present, right? So we create a new behavior subject, and then we set some data to it, and we expose it as an observable to make it read-only. With our signals, we can migrate easily, in a sense, by replacing the behavior subject with a signal using a default value. And then we expose our signal as read-only. And that becomes a read-only signal that other components can only read. And in here, we would do our setter to change the data of that signal. So the translation, before, that's a behavior subject. After, it's a signal, right? And so what's important to mention here is that there's the difference in terms of syntax, but there's also a big difference in terms of what you have to do with signals versus what you have to do with RxJS. And I see a few comments in the chat about cleaning things up and subscriptions. With signals, there's no subscription. You do not subscribe to a signal. You just read its value. And when a component reads a value from a signal, it's kind of registered as a dependency of that signal. So Angular knows exactly which part of your code are consuming information from that signal, right? And so if so there's no subscription, there's no unsubscription. It's all taken care of internally by the framework. You don't have to worry about it. You don't have to do an ng destroy and use all of these different strategies that we had to unsubscribe with RxJS. All of that code can go away. No more async pipe either. You can really change a lot of things and simplify your code quite a bit just by the fact that we don't have to subscribe, unsubscribe, clean things up. It's all done automatically. It's, you know, it's native. It's an Angular native feature. So it's not a dependency like RxJS, which means Angular has full control over our signals. And yeah, that's a big improvement. Still, in some places, you might still want to use observables, or you have observables that you want to convert into signals. And a common example of that is going to be the HTTP client, right? Because the HTTP client still returns an observable, and maybe you want to turn that into a signal in your code. So we can do that. There's a utility function called toSignal, and toSignal can take any observable as a param and turns it into a signal. And so the idea is that you can also pass a default value to signal, which is important because a key difference between a signal and an observable is that a signal always returns something, whereas an observable, you create it or you get access to it, and then you have to subscribe to receive something later on. With a signal, you can create it, you can call it instantly, and you would get a value. Now that value might be undefined or null if you didn't have a default value, but a signal always returns something. That's important. And so when you create a signal out of an observable, it might be better to provide a default value as a param, so that you know that your consumers always, the consumers of the value of that signal always receive something. And the opposite is true as well. You can turn a signal into an observable if you ever wanted to. So I guess this could be useful if, for legacy reasons, you have complex chains of operators that you don't want to lose, or that have complex logic that's just working, and you want to keep using that. You can turn your signal into an observable temporarily to go through this, and then return the value as another signal, for instance. So yeah, RxJS is still here. We can still interoperate with it. That said, in the long run, the goal of the Angular team is to really make everything, or as many things as possible, signal-based, right? And they said it on stage at NgConf a few weeks back, that the goal is to really have a future of Angular without Zone.js and RxJS. So possibly being able to do all of that without these two dependencies. Oh yeah, that's an example with a default value here. So as I mentioned, signals are synchronous, always return a value immediately, very much like a behavior subject. And so in this example, I use toSignal, pass an observable to it, and then I have my initial default value. So when you start using signals, I find that they improve readability. And I give a big block of code as an example here, which maybe is not the most convincing way of saying that this improves readability. But I have one computed, I have two computed, one toSignal. It's all one line of code every time. So instead of having, you know, observable.pipe.operator.do something, you can do a one-liner with these computed, which really makes it a lot easier to read what's going on. And you know, you don't have all of these operators to know about. So it does simplify and improve readability. So what becomes NgRx in all that? I'm almost going to skip those slides because it's going to be our next talk. So we have NgRx Signal Store, and Rainer is going to cover that just after me. So just stay tuned for what's coming up next. I'm going to skip and get to what's next for signals. So signals are officially available in v17 now. And that's important because it used to be in developer preview. not anymore. The signal function and the computed function are out of developer preview. They're officially available. I think effect is still in dev preview for now because the Angular team wants to figure out a few more things on effect before making it officially part of the framework. But the idea, and what's going to happen really in the future, is that Zone.js is going to become optional. We'll have that localized change detection thanks to signals. The Angular APIs are going to get simplified. So wherever we had observables, it should become signals. And then the ecosystem evolves. So all of the libraries adapt to it, like NgRx started doing that, and other libraries do the same thing and start using signals more and more as an alternative to RxJS. And the main transition that's happening, and it's been the case with Angular 17, 17.1, 17.2, 17.3, is that we started seeing these APIs that are all about enabling signal-based components. So signal-based components are the future of Angular components. They're really how we are going to be able to have that signal-based change detection where everything inside our component becomes signal-based, right? And so this is all in developer preview right now. You can use a signal as an input. You can use a signal as a model. And you can use an output function that is not a signal, but it's not an observable either. So the output has been rewritten to be independent from RxJS, because it used to be the event emitter from Angular used to be an observable. If you use the brand new function output, then it's not an observable anymore. So input looks like this. It's meant to replace the @input decorator. It comes with a few different benefits. You can specify the type of the input. So the first one, like here, first name is an input of type string, doesn't have an empty value, doesn't have a default value. So the type is really string or undefined. The second one, last name, is required. So you can do input.required of string. And as a result, the type is always string. And you would get an error if you're not passing an input last name to that component. And the last example, input of 0 is always a number because it has a default value of 0. So that's input. Something new that we get with signal-based components and didn't really exist before, or not to that extent, is the model function. And with the model function, you can create a signal that's both an input and an output. So just like ngModel in a sense, but all signal-based. So you see this example, I have first name equals name, age equals age. These two are models. So they are two-way data binding that works both as an input and an output. And I'll show you a demo of that, an example. Let's go to my other component here. So that's our component called name entry, and it uses two models. One is first name, one is age. So these are both inputs and outputs. So they are writable signals, which creates the equivalent of a two-way data binding. And so we can get the default value and we can change it. So this is loading slowly, but you'll get the idea. So here we have our component. So we're passing a first name of Angular, an age of 21, according to these two signals. And we have buttons in the child component that would change the value of the first name to Al and increase the age by 1. So I just keep increasing the age. And I'm doing this. So these two buttons are in the child component. They change the value in the child component. But because we have models, these are two-way bindings. So the parent component, the main component, receives those updates and displays them. So that's a two-way data binding. And that's also in developer preview. And the last one, the last of these functions is the output. So that's how you can replace. So you can replace your inputs, you can replace your outputs. All of these remove the dependencies on observables and allow you to have a, signal-based approach. Even if the output is not actually using a signal under the hood, but it still has the emit function, just like before. And if you ever need to turn it into an observable, there's an output to observable function. And I think there's an observable to output as well. So you can really do anything you want, right? And get feedback. Get all of these features available so you can really start using them without breaking everything. You can still have that interoperability, keep observables where you don't know yet how to remove them, or you can't. You can use those functions to still interact with those other observables. And we also have view child, content child, view children, content children. So all of these decorators that used to be observable based, they are now signal based using functions. Same thing. So these return signals now instead of observables, and it's also in developer preview. So things are moving very quickly. The timeline is kind of like this. Future, so V17 support for inputs, outputs, and queries. We are there. Signal-based APIs have started. Fully zoneless apps, not yet, but maybe, in the near future, Angular 18, 19, maybe 20. Oh, no, 20 would be pessimist. Probably faster than that, because things are already moving quickly. But yeah, that's really where we're going. So the future is about more signals, not less. And that's everything I had for today. So I know we have a Q&A at the end. If you want to do that, we have a few minutes to get into the Q&A. I added the link to my slides, email address, my blog, all of the info. And as I promised, there's a coupon code NgLove24 to get $20 off any course of certification exam at angulartraining.com.
Thank you, Rainer, for this great presentation and for the code for our community. And as you have mentioned, we'll start with the Q&A because there are already some questions. So let me bring them on. So first from Mayank, how to decide between RxJS and signals?
That's a very good question. I would say you, in the current state of things, I would only use RxJS if I don't have any other option. So you're using HTTP client, the HTTP client returns an observable, you have to deal with that. But everywhere else, if you're creating something new and you're thinking RxJS or signals, I would say go with signals. So start using them as much as possible, because again, the Angular team is thinking about this future where everything is signal-based. So if you're writing new code that goes in an RxJS direction, it might be something you would have to update later on and migrate. So that's why I would say signals first, RxJS second. That's really the mindset. And that's how I would decide. So you can do the same.
Yeah. Okay. Let me bring another question from Adam. How to integrate signals with reactive forms? What's the best practice to react to status change, value changes of form controls using signals?
Yeah, so that's one of the APIs that's work in progress in the Angular team, making everything signal-based. So this is going to happen for these observables as well from reactive forms. For now, you can use the toSignal function if you want, right? So if you really want to start using signals with reactive forms, you would just use toSignal on that status changes or value changes, and then you get a signal out of it. So you can definitely do that if you want to, but it's kind of a work in progress right now. We're really in an in-between situation with reactive forms, so it's not ideal yet, but it's going to happen.
Okay. There is also a question from Hamed. What is the difference between computed and effect?
So computed returns a value and effect doesn't.
Okay.
So computed returns a new signal with a new value that's computed from any number of other signals, right? Where effect doesn't return anything. Effect is just a way to say, when this signal changes, do that other task, do that side effect.
Okay. There is another question from John. Can you elaborate on the concept of view that you have mentioned, the idea of structural directives like ngIf creates a view inside the template, for example?
Yeah, so a view, and I think the Angular team writes it really well in the documentation of the framework. They say that the view is the smallest set of instructions that Angular needs to update a part of the DOM in our components. So the compiler is basically creating those views, creating these instructions that update the DOM. And when we use structural directives, we create views in the compiler that knows how to update those subsections of our templates, in a sense. So when you use an ng container, ng template, router outlets, I guess all of these things create views, in a sense. So they create a part of our component that's dynamic, that can change over time, and that the compiler has specific instructions from. So that would be the way to visualize what a view is, really. But yeah, and we don't really have to know about it as Angular developers, right? You can write Angular code without ever knowing about these views. They just become important in the sense that signals are going to be able to update individual views rather than components. So they make change detection extremely precise compared to what we had before.
Okay. There is another question from Florin. Some of the questions which were already answered by the community, I just skipped because there is like a lot of them and wouldn't be able to ask all of them. So when Angular will be ready to not require Zone and JS anymore, we will be forced to update all the NgRx code to use signals if we want to our app continue working.
Okay, so when Angular will be ready to not require Zone.js anymore, there is no official date on that, but I would bet for Angular 18 or 19, I would say. It seems pretty close. So, by the end of this year, I think it might happen. But again, it's just my prediction, right? There's no there's no official date. So it's just me predicting. Will we be forced to update all our XJS code to use signals if we want our app to continue working? No, you don't have to do that. You can still use RxJS now and in the future. Removing Zone.js and removing RxJS is going to be optional in the foreseeable future. So you don't have to migrate everything if you don't want to, or if you cannot. It's just going to become optional. That's the idea.
Okay. So I will just choose two more questions. How to update the value of signal when another signal will change his value?
Well, that's a perfect when a signal. So that's how you can create dependencies between signals.
Yeah, so I will need to ask you to explain it again because we had some connection issue. Sorry, we couldn't hear. Mm-hmm.
Yeah, no problem. So update the value of a signal when another signal will change its value. The idea is to computed is really what we need for that. So computed is the function that takes a signal or two or three and derives a new value out of it, right? In some cases, you might use effect to do it, but if you try to update a signal within effect, you'll get an error by default. You get a warning from the Angular compiler that says, oops, you should not do that, because it's typically dangerous and can create, infinite loops of updating stuff. So Angular would warn you if you try to do things that it doesn't like. But yeah, computed is what we should be using. Effect can kind of do that work, but not recommended typically.
Yeah. Okay. There is another question from Marcus. Can you explain untracked a bit in detail?
Can you explain untracked a little bit in detail? So untracked, I've not used it that much, so I won't go into too much details into it. But the official definition for it is that it would prevent unnecessary dependencies to reevaluate any computed effect that depends on a value when it changes. Which is, yeah, we would have to go a little bit too much under the hood with the time that we have left to get into untracked.
Okay, so let me bring the last one, like any fluffs of signals.
Well, I guess the best answer to that is that signals come from Angular, and they are used in YouTube, which is used by millions of people every day. So if there was any flaw or anything obviously wrong with them, I don't think Google would have done that, right? And start using signals on probably their biggest product that's used on all mobile devices, website, and everything every day. So yeah, that's my answer. If there was anything wrong with signals, I don't think they would be more and more popular and used all over the place, and that Angular would bet pretty much everything on them.
Yeah. Okay, so that was the last question. So Alain, thank you for your time. It's been like absolute pleasure having you as a speaker. Your presentation was very informative, and we hope to see you again in our future meetups.
Yeah, no problem. Thank you for having me.
Have a good day. Bye.
Yeah, you too.
So as we saw, based on the signals, Angular undergoes massive changes in terms of reactivity, but also server-side rendering. Based on that, House of Angular decided to create an ebook titled Ultimate Guide to Angular Evolution. If you want to know what features were groundbreaking from version 14 to the latest one, I strongly encourage you to download that ebook, to which link you can find in the chat. And right now, let's dive into our second presentation. It's a pleasure to introduce our next speaker, Rainer Hahnekamp. He's the author of NgNews, a trainer and consultant in the Angular architects. So remember, guys, to follow his work on the YouTube and Twitter, where he provides a weekly brief overview of relevant events in the Angular ecosystem. Rainer will talk about the NgRx signal store. Welcome, Rainer.
Hello, Mateusz.
Hello, how are you doing?
Nice to be here. Thank you.
Yeah,
I'm
nice
fine. I'm fine. You too, I hope.
So same as to the Alain, I have like the two questions for you. First, what's motivated you to create NgNews?
What motivated me?
Yeah.
That's something nobody asked me before. It has an interesting background story. So I wanted to contribute to the Angular community. And my initial idea was that I do the translation of the Angular documentation in German language. And that didn't turn out or work out, like, let's say it like this. And then I had a discussion with Manfred, my colleague, and I had this idea of kind of bringing up a newsletter. And I said I want to do a little bit special. I want to do a video in the form of a newsletter. And yeah, he encouraged me to do it. He said, yeah, maybe that's even better than the German translation, because the Germans, they should learn English. And that's the way how it started.
Yeah, and I have to say it's like really awesome for like every Angular developer, especially now when so much change and we don't always have a time to follow everything, so we can watch the NG news and we know what's happened in Angular community. So
thank you.
That's awesome. So thank you for that work. And another question is like about your work with Manfred in terms of the trainings and Angular architects. If you can briefly say us what's you guys mostly focus now on, and what is like the famous training course picked by community right now?
Yeah. So I mean, we are focusing obviously on Angular. And I'd say the most prominent and the most sold one is definitely the enterprise workshop that we have, where we are dealing with micro frontends, architecture, also state management, of course. This is mainly Manfred's works, and I more or less specialize in testing, also state management a little bit, TypeScript as well, and some other stuff.
Yeah. So yeah, that's awesome. Your work is awesome. Like your blog posts and so on, guys, are just sometimes way to go for a lot of teams. So keep going.
Thanks.
And
we will.
We're taking like more time. The stage is yours, and we'll see in the Q&A session. Good luck.
All right. Thank you, Matthias. Good. So the first task is that I try to share the screen, and yeah, you should see my slides hopefully. Good. So welcome to my talk about the NgRx Signal Store. I already had a little bit of an introduction, so I'm going to make it short. So my name is Rainer. I'm part of Angular Architects, workshops for Angular. As I said, I'm doing this NG News. Also said already a little bit about it. And I also have my other YouTube channel, my private one, where I am posting videos most of the times about Angular. The agenda, or the way how I want to do it in this talk, is that we will have an application which uses already signals, and we will do a refactoring towards the signal store, and we are introducing its features step by step, I would say. But first, a little bit of a theory, why you want to use the signal store and why is it actually necessary. I have 4 reasons for you. So the first one is, when it comes to the signal store, I mean, it's a state management tool, and it's a very special one because the state internally is a signal. So it's not like some different data structure that the signal store has, but it's really, the state is a signal itself, which means we have some advantages, especially if you are a developer of the signal store, because you inherit all the functionalities, and for us developers, all the rules that come already with signals. So we have those kind of reactivity, we have the glitch-free effect, we have the immutability, the requirement for immutability, and also the derived values that computed. So this is something you don't need to reinvent because signals give it already to you. The other reason is, I mean, we have seen before in Alain's talk that signals are very simple to use. We have just 3 functions, not more, very easy. But nevertheless, if you have larger values that you want to store in a single signal, then you very soon hit some kind of boundaries. So you will see them later on what I mean. But you need you need more function in order to manage those kind of signals. And this is exactly what the signal store gives you. It's also a structured approach. This is something which I really like from the NgRx global store, the old one, that it kind of enforces a certain structure. The code is organized. And if you're entering a project and you have no idea what this kind of code looks like, then the signal store at least a little bit says, okay, this is the place where the methods go. This is the place where the derived values, the computed go. And this is the place where the state has to go. So there is a little bit of structure there already, which is also very nice. And the main benefit, I would say, and this is even to me personally, that's the reason why I would favor it over this global store is its extensibility. So you can very easily come up with your own extensions that you can then apply to other different signal stores. Good. As the Angular signal itself, the signal store or NgRx signals is mainly consists of functions. They also call it sometimes standalone functions, some of them. And you see here in this illustration, again, everything is based on the Angular signal. So this is where we start. And then we have two functions which are called patch state and Rx method. These are functions where you don't necessarily require the signal store. There is also a lightweight, I would say it's between a signal and the signal store. That's the signal state. And you can use the patch state with the signal state together. And Rx method is something you can even use without the signal store. But of course, we will take a look at that one later. And the signal store itself is a function, but it comes together with all these other functions, which you see here in this green rectangle. So with methods, with state, we will go over all of them. And yeah, so you can, in a way, kind of build your store step by step by adding one function after the other. That's the basic idea. Good. So I would say let's take a look at the application. I said before we want to do a refactoring. So the application, this is StreamYard. This is the application. This is my usual application, which I use most of the time. So we have here some kind of holidays, and it's coincidence there is now a holiday for Poland. And the nice thing is that this holiday has some kind of a quiz. So we have here like what's the national dish, what's the currency used, and so on and so forth. So a basic quiz, more or less. I can click on some answers here, and as you see, there are some additional functions. So whenever I click on an answer, it says if it's correct or incorrect. And we also have here something like a countdown. So I only have 3 minutes time to finish here this quiz. So this is where we are focusing on. If we take a look at the code, then we see that this is here the quiz component. I hope nobody complains that I'm using the light mode. Last time somebody said I can't look at it. I should use the dark mode, but then I'm getting blind. So yeah, I hope that's fine. But yeah, in the end, this here is the quiz component. It has, of course, a lot of HTML, as we see here. And we also have here quite a lot of TypeScript. So as I said before, this is all based already on signals. So we have here a huge signal, actually, which is the quiz signal. It contains the title, the questions, and also the time in seconds. And based on that quiz signal, we need to come up with derived signals, namely for questions, title, and time in seconds. So those are derived signals. Why do I need them? Well, because they are used in different parts of my component. So, I mean, it could also be a little bit different, where maybe I would say this component, I want to split it up into multiple subcomponents, and then maybe one subcomponent gets the questions, the other one gets the time in seconds, and so on and so forth. The main point here is that I have the need to take one huge signal and split it up into multiple pieces. This is what we have here. What else? We have here the status. This is the one that shows me how many questions I have already answered. This is computed, so a normal signal. Nothing very fancy. Then we have here an effect. So we are working here with an input property where I'm getting the ID for that particular holiday. And from there, I use the ID to get the questions. Then I have here my countdown. This is done here with RxJS with an interval. And then last but not least, we also have here the answer function. I mean, it's not important what is inside of the function. It's just important that we have those kind of elements. But there is, of course, a function when I click on the answer that decides if it is correct or incorrect. Good. And the goal now is that I take all the TypeScript code. I will leave the template in the component. This is where it should belong to. But I want to now refactor this component and extract this code into the signal store. And we will start with the basic functions. And these are the signal store itself, which contains a certain state, and the two functions that allow me to read and to write data from my signal store. Good. So what do I have to do? Well, first of all, I have to select the values for my state. And as I said before, everything derives from this quiz here. So I take here this object literal that I have, and I'm going to create my quiz store in a separate file here. The way how it works, you say signal store. It's just a normal function. And inside of this function, you can now start to add your features. And the first feature is the state feature. So we have to require, or we need to have some kind of container where we can store our data. And that's the function for that is with state. And this is where I'm putting my values first, my initial value. I also need to type it a little bit because with an empty array, we are not getting very far. Otherwise, it's a never, never. And of course, I also now need to do something with the value which is returned here. And the signal store returns me the class. It returns me a class. And that's why I'm not saying quiz store with lower capital, but I have to start it with uppercase. Because this, it looks a little bit unfamiliar, but this quiz store is not an instance of the signal store. It is a class. So it has to be instantiated. It's not instantiated yet. Instantiation works now via the Angular's dependency injection. So I could here say I want to have this as I want to have the quiz store as a service which is provided globally. But I could also say I want to go with local state management. This is what I'm doing here, which means my component needs to provide it. So I say here, as I would do with any other service, I would say here, I want to, I think I also need to export it. I need to provide here the quiz store. Good. That's the first step. Now I need to inject it. Quiz store, not quiz service. And the question is now, what do we get now? What does the quiz store return me? If we go into the constructor, then we can see what this is all about. So if I say here quiz store, then we see that it all of a sudden contains the three properties that are already in my state as, it looks like as normal properties. But that's not true. I don't get here an array of questions. I don't get a string of a title, but these properties, they are slices. So they are already signals, which means if I have already a signal for questions, title, and time in seconds, then I don't need to create them manually anymore. I can just assign them here to these variables. So I can say, well, I don't need to compute it. The computation has already happened. I just need to say quiz store and give me the questions. I mean, it didn't happen. It happens the first time that I access it. It's generated on demand. But let's just say those signals are already available. Now I can do the same thing then also for the other points. So I could say here, yes, quiz store. I just want to access title time in seconds. And you see here that IntelliJ immediately understands that this is now of type signal, question array, signal of a string, and signal of type number. So this is this kind of reading part, which I get for free. I just need to put the value into a signal store, and I have those slices. They are also nested. So if I would have here some kind of an object literal, which again has an object literal, then I can go into it, and I would also get a signal from those nested objects. Reading is not all. We also need to be able to write to a signal. And in order to write to a signal, we see already that there is now a little bit of a problem. Not really, because here now we have a problem, because here it says, well, quiz set is not available. Now, of course, it's not available. I've just removed it. But when I want to set the data, I can't set it. The signal store itself doesn't have a set and doesn't have an update method. What we have instead is that we have a patch function, because we say, yeah, with a normal signal, I would say update, I could say set, I could provide all the complete value all the time. But with a larger object literal, very likely I only want to update parts of my signal, not the complete value. So I want to patch it. And this is also what we get here. We have a patch function instead. The patch function is a standalone function. So I have to say patch state. And I can say here, okay, this is the store that I want to update. And I want to write now the quiz data into it. This is everything which is necessary. I mean, at the moment, I'm using patch state to override the complete value, but I can also do it for partial values. Partial values are used here in this answer, because the answer method only updates the questions. And we see here that this kind of immutable function needs to clone the current quiz, and then it just adds here the new questions. And here I can say, I don't need to clone it. I just say that I want to update the questions, and the rest of my quiz store should stay as it is. I don't want to touch it. I don't even want to know what's inside of it. So what do I do? Well, I say again, patch state, and I say this quiz store. And then I say, I want to update now their questions, which means I take this part here, this questions map, I copy it here. And of course, quiz does not exist anymore. We know this already. So I say here, quiz store questions. It's a signal. We know this already. Run the map. And I don't need to care about this cloning feature here anymore. And I am almost done. So we can go back now to my application and see if it's still working. Yeah. So reload. Yeah. Take a wrong one. Yes. Yeah. Counter is working. Status is also working. Data is also there. Everything works. So this was the reading and the writing part. Very easy. Slices and patch state. The next one is this kind of structural part where I said this signal store requires or forces me to structure my code in a certain way. Which usually with large signals, we also have the requirement to add logic, obviously. And there is a certain place where the signal store says, this is where you have to put your methods. This is where you have to put your logic. And this comes with the method with methods, obviously. Question, do we have somewhere a logic? Yes, I would say answer is already a logic part. And I don't want to have this inside of my component. I want to move it to my signal store. So I copy it, I cut it out, then I go to my quiz store, and instead of saying now with state, I just say, okay, I have now something else. I have those methods which I want to add to my quiz store, and what with methods is now doing, that it expects from me. It gives me, first of all, it expects from me a function, and in this function, it gives me the current store. So I could inside of this function access my properties of my state if I want to. What is expected from me is that I'm returning an object literal where all the properties are methods, which should then be added to my quiz store. Well, and at the moment, I just have one method. I only have this answer method. So I say, okay, then I just return something. I return an object literal, which is answer, and copy this function into it, which I have now taken out from my component. We see already here some errors. That's obvious because this questions does not exist. We are now inside of the quiz store, but I can just very easily say, okay, we have access to the store here. So I just need to replace this. And here again, just say, okay, just go with the store, and then everybody should be happy. It's just a simple copy and paste what I've done. We are not done yet. First of all, the question is, how does this answer method now look to the outside? Again, constructor, quiz store, and we see now immediately next to my slices, I'm now getting this answer method, which has the same signature as the other one, and I can now use it right away. I'm going to use this answer method directly in the template because I don't think I need to come up here with a special event handler. Of course, you could do something like handle answer, and then you internally just call quiz store answer. But yeah, I think that's acceptable if I do it here directly in the template. Good. Do I have some other logic? Yes, there is something else, which is the loading part. So we have here a quiz service find by ID. And this is something I also want to now extract into my signal store. So I say, okay, I have here a load method. This will be an asynchronous task. So I can also say here async. We've heard before that maybe we don't want to use RxJS all the time. So we have a comeback of the async await. And I say I have a quiz ID of type number. And well, now I need to get access to my quiz service, which is fetching me all the data. The problem now is, how can I here access the dependency injection. Unfortunately, I can't do it here, but I have to do it before my with method returns something. So in this space here, the code in this space here is executed in the injection context. So I can very easily say here, yes, before everything starts, now is the time that I say, hey, look, I want to have access to the quiz service. And you see already, there are some discussions about inject versus constructor function. I would not be able to use the constructor here because there is no class. There is no class inside. It's all just functions. So without the inject, that wouldn't even have been possible to do something like this. Good. We have here a task to do. So I say here quiz service find by ID. I say here, yeah, this is the quiz ID. Well, I can say, wait, this one returns me already a promise. And well, I just use the patch state function in the same way as I've done it before in my component. So I say patch state. Access to the store is there. It's just a store. I can use the await here as well. And well, that should be it almost. Of course, I also need to update my component. I always wait a little bit if the compiler here at the very bottom doesn't show me any error messages. Looks good so far. And yeah, inside of my effect, I need to change now a little bit. I need to say, okay, maybe I say here quiz service, not quiz service, just quiz store. Quiz store. No, load. And I say this ID, just call it. And I could leave the untracked if I want to. We will see if it works or not. So I'm just doing this in my effect. Good. Wonderful. Data's there. Countdown is shown. Functions of the answer function is still working. Great. So we have now moved all the methods, so this kind of logic, the answer and the loading logic into my signal store. So the component gets more and more or less TypeScript code. Good. Next thing. Next to the logic, we of course also have the demand for derived values. So I need to find a way how I can add my compute hits into the signal store. And no wonder there's a function for it as well. And this is the third major function next to with state methods. It's called with computed. And with computed is very simple because, as I said before, the signal store contains the state already as a signal. So it doesn't have to reinvent the wheel. We can just use the computed function from Angular itself. Question is, do we have something which can be computed? Yeah, the status looks like a good candidate. Here we have a little bit of complicated computed. So let's just copy that one and go back to my quiz store. And well, here I can say after with methods, I have a new with function. This time it's with computed, works in the same way as with methods. It gives me the state and it expects from me, from my function, that it returns an object literal containing properties which are generated by computed. So I say, okay, I have here my state and I'm going to return an object literal. And this object literal contains only a status property, which is using computed. And of course, you also have to change here again. This does not work anymore. So I access here state questions, and that's it. That's it. Yeah. So very simple. With methods was a little bit more complicated with async await, with the injection context and all that stuff. But here with computed is, I would say, very straightforward. And in the same way as we had the load method and the answer method, my quiz store in the component also gets now access to the status. So once again, let me take a look. Quiz store, we have here the status. This is now this kind of signal, this computed signal which we have. And I'd say I use it again directly in the template. So I don't create here an artificial property. I just use it here directly from the template. So I say here quiz store, just access the status, and I'm done. Yeah, we can already start to remove things. So the quiz service is not required anymore. And now it starts to become a little bit more interesting. But let's quickly summarize, because what we have seen so far are the basic things. So we can manage the state with state. We add the logic with methods. And for the derived values, we use the with computed. In order to read data, we get the slices, just normal signals. And in order to write data, we have this patch state function. That's it. Very simple. Good. What comes next is RxJS. So in some cases, we might want to use RxJS for certain tasks. There was a question before, when should we use RxJS? When should we use signals? Yeah, I would say use signals as long as you can. So I have the same opinion as Alain, and I think everybody else from us also shares my opinion. But with Rx method, I have the possibility to use RxJS in a very good way. Let's put it like this. Do we have a use case for it? Let's maybe ignore the interval for now. This comes later. Let's just say here with the loading thing. So when my ID changes very often, then of course I have a problem, because now multiple HTTP requests would be triggered, and I want to use RxJS for that to manage it. So I say, just in order, or just in case this ID is kind of switches or changes its value 3 times, I want to use a switch map for the HTTP request, because I want that when a new ID value comes in, that my request, the former one, is canceled. Now, this is something which is very easy with RxJS. So how do we do this? There is this Rx method, which we can now use in order to generate a new method. So I call this here, that's the old one, that's the underscore load. And I now create a new load method. And I can now use Rx method. Careful now, because this is a little bit complicated if you see it the first time. Rx method is a factory function. So it's a function that generates me another function. And I can now say what kind of parameter, what type the parameter of this function should have. And I say, well, the load method does already have a quiz ID, is of type number. So I want that my new load also has its first parameter as type number. Very easy. And to the outside, this load method, that we have here, looks like a function which expects now a parameter of type number. But internally, for the implementation, Rx method deals with every function call like an observable has emitted a value. So for me, to the inside, I could now say I have here a pipe method. So I could pipe to the function calls, and I could then treat those function calls as if an observable of type number would have emitted a value. Again, if I in my component would say load 1, load 2, load 3, then this pipe, this observable which I have here, would emit 3 times those numbers. And I can now use the normal RxJS operators, for example, the switch map, in order to control those multiple events. That's now a perfect use case for RxJS. So I say here, I have my switch map, and the switch map gets the ID. You see here already, ID is of type number. So type inference works perfectly. And I say, okay, quiz service, do now this find by ID here as well. The switch map also knows how to deal with promises. It's not only about observables. And once I'm done with it, I have a tab operator. I have a side effect in that case, where I say, well, I have now my quiz data, and I want to now update my state. So I say here patch state, store, and add the quiz. And that's it. Of course, there's also another one. There's a tab response, but let's not complicate things. The point here is I can now call the function as often as I want to. Internally, I'm dealing with it as I would have done it with any other observable. Which means actually to the outside, nothing has changed, because here the quiz store load still calls load with a type of number, and that's correct. Why not? This is exactly what I have defined. I said the Rx method should have of type number. So if I now go back to my application and reload it, I go to holidays. It's a little bit slow. It's very slow. Hope there are no errors. No, we are here. Yeah, right. It's working. Counter is also running. Give me back my dev tools. So, you might not say, okay, that's cool because I can now control those events with the switch map, but I can do even more. Because this Rx method doesn't just generate me a function which expects a number, it also is now a function which would accept an observable of type number or a signal of type number. Which means I have here actually a signal of type number. Well, I don't need the effect for it because I could say quiz store load, and I just provide here this ID. I'm not calling the signal. I just provide the signal as it is. The Rx method is now smart enough to understand that this ID is now a reactive type, and it would re-execute, or it would or the internal observable would emit every time where the signal also triggers a change. So in this case, the effect is not necessary anymore. Everything is taken care of by this Rx method. Unsubscription is also not a problem. The signal store takes care of it. Now let's see if it works. So I go back, I reload it. Yeah, counter runs. Wrong answer. Perfectly, everything works correctly. Good. So this was the easy one. The easy was the entry Rx method. We still have another one. We have the interval. We have the countdown. Because I also want to implement the countdown with the Rx method. That's a perfect fit. Because I have here already an interval. There is already an observable there. So why not combine it with Rx method? What this one is doing, it says, well, every time, every second in this case, it is updating in my this time left signal, and it says, yeah, the way how I countdown works. I think I don't need to explain it to you. So what I want to do now is that first of all, I want to create now a method in my signal store that updates the time left, and then I want to use the interval in combination with the Rx method in order to call the update time left method every second. This is my goal. So what do I do? What do I have to do? Well, first of all, there are some additional properties that I have to add. I have to add here time started, time left, and time in seconds. They also are now, time in seconds is already in my signal store. So I say here time left is 0, and time started, I think, is a new date. So we start with now, time started, right? So now we have that in our state. And then, as I said before, I say here update time left. It's a normal method, so we don't need Rx method for that now. And, or let's just use Rx method. Let's shorten things. So I say here Rx method. I say, I actually don't care what you give me. It's just important that you can call me. So I say here unknown. And every time I'm being called, I will just use here again a tab where I say pipe tab. Careful. Where I say I'm now doing the recalculation of the uptime of the time left signal. So I can go here. Now I can say, okay, this function that we have here, this time in seconds, gets now into my tab one. So here I say patch state. I have access to my store. And then I say, I want to update the time left, and only that. And I don't care about the rest anymore. So I say here store, and here also store. And this is what I want to do. Okay, so to the outside again, update time left. is now a simple function which expects an unknown parameter. So I just need to call it, and that's it. And I use this Rx method, this update time left now, to provide not a signal, but the other reactive type that we have, namely an observable coming from the interval. So I just say here, okay, update time left. Here you have an observable which emits every second a value. Use that one and update then the time left. How do I do this? Well, I would require now some way on how to start this interval in the very beginning. So when my signal store is actually instantiated, and there is a function for that as well. And that one's called with hooks. And with hooks, again, it's always the same mechanism, the same principle. It gives me access to my store. And it says, you can return me 2 different hooks. I just need one. I say I only want to provide here a function when the component is initialized. So I say here the hook is on init. And then I say, okay, we have here this kind of server-side rendering in place. So that's why we have here this server and also in the component. So I need to move it here as well. We are running here in the injection context. So I can say is if platform is server, inject the platform ID, then I just want to return, don't want to do anything. But if not, if I'm running in the browser, then I want to go to my store and I want to say, hey, look, update time left. You are an Rx method. You run now every second. And I can give you this interval which emits every second. And just to be sure that we start immediately, I also have here a pipe that says start with 0. This is what I want to do. Now my time left is updated every second. And the only thing that I have to change now again is that I need to refactor it inside of my component so that the time left and all the other values are now coming directly from the signal store. Yeah. So here this with hooks, again, it's just a simple object literal that I have to return on init. The other one is obviously on destroy. Good. So let me go back to my component. So I can say here, well, this is something I don't need anymore. Everything that the constructor has to do is that it has to connect the IDE with my quiz store, which it has already done. And do I need something else? I don't need the time left. The time started comes now also from my signal store. And the server is also not necessary. So it's now very few code left. The major part is, of course, in my template. And here we have our time left. So I say, okay, here and here and here. You know what's coming. Quiz store, access the time left. Time left is again a deep slice, a deep state. So it's also here a signal. Now I can save it. And if everything works fine, the application is still working. So reload it, countdown runs, answer is also working. Wonderful. I'm done with it. Last thing, and then we are really done, are now the extensions. And here I'm not going to live code them, but I have already prepared them. So I'm just going to copy them and explain the existing code. So extensions means whenever you say you have something very useful in your signal store, which you might want to use in another signal store. So maybe not in the quiz store, but maybe we have, I don't know, a gallery store or I don't know, something else where we, for example, require a countdown feature. So something what I've done just right now, then I can create an extension. And extensions are extremely simple, are extremely easy to use because you don't have to learn anything new. I just say here, I have a new extension. I call it with countdown. So with countdown TS. And as I said, I have already prepared it. And this is the way how it looks like. Let me quickly import all the things and then we can. No, why is this not working? Add all imports. There are some things to import. If I would have been clever, I could also have copied the import statements before, but yeah, we have it already. Good. What I'm doing here is that I just call signal store feature, and I reuse the same methods that we have already used before with state, with methods. We could also use with computed if I want to, in order to generate some kind of a partial state or as a certain state feature, which I now can use and plug it into my existing quiz store that doesn't have to deal anymore with the countdown logic, for example. So we have here time left, time started, time in seconds. These are state properties which are already here. I don't need to redeclare them in my quiz store. And the same is then also true for those methods. So I say here, I have here some hidden methods. I only expose one, and that one is here the return, the start countdown. So my quiz store can call it just by saying start countdown, time in seconds, and then the countdown starts here internally. Yeah. So how does it look like? Well, I have here my with countdown already. So I say, okay, I go to my quiz store. I say those things, those state properties, I don't need them here anymore. These are part of the countdown feature, so I'm going to remove them. We see immediately we are getting here some errors, obviously, because the state doesn't have those properties. But everything I have to do is that I now just say here, or maybe even before, I have to do it before I actually access them. So I say here with countdown, call the function, and you see all of a sudden the errors go away, because time in seconds, all those properties are back again. You can also take a look here. So time in seconds, time started is already there. And we also have here start countdown. And this is now something which is a little bit different in terms of the implementation, because I can't use the hooks anymore. I need to wait for the quiz to tell me what kind of time has been decided for this quiz. So what I have to do here is that I have to remove it here from the with hooks. Don't need them anyway. And I say, as soon as my loading happened, where is it? So here we have this tab. As soon as I have access to this quiz entity, I can already start with the countdown, because then is when I know the time in seconds. So I say here at the very end, after I have patched my state, I just say, okay, look store. Now it's time to start the countdown. And well, you just take the time in seconds directly from the quiz. You already have it. And if everything works fine, that should be it. Yeah. So a little bit of an, as I said before, of a change in terms of implementation. It's not in the hooks. Now it's in the load method. But I think the advantage is obvious. It's very easy to come up with generic functions you can then plug into different stores. That's key here. That's this extensibility. Let's see. Reloading, countdown works, wonderful. And this also works. Great. Yeah, and this is the signal store feature. This is for me personally, that's for me the main, as I said in the beginning, the advantage why I want to use the signal store, or why I favor the signal store compared to the global store. Good. Summary. We're already done. So we have seen that the signal store embraces this Angular signal. So it is built on top of it, which means we get all these things for free. We have an extension to the signal with required features like patching a signal, like getting nested signals or slices, as they are called with the signal store. We have also seen that it is now very easy to combine asynchrony or asynchronicity with signals. That's not very hard anymore. And we can also add RxJS, but in a very elegant way. We can really pick a certain method and say, well, here exactly is where I have a use case for RxJS, and here I want to use it, but not in my other code. Very easy with Rx method. This kind of structured, we've seen with computed, with methods, with states. So there is a structure in our code, and that it is highly extensible is something I have already shown you. Yeah, and we can use it also for global and local state. So the signal store also has a config, which I haven't shown you, but it's very easy to say, I want to provide the quiz store as a service provided in root, and then you have global state. Here, I went for the local state. There are some extensions from us as well, from Angular architects. So we have, for example, extension for the DevTools, for the Redux DevTools. So if you want to use the signal store and you want to see the state of the signal store in your Redux DevTools, then there's an option for it. It's just a with DevTools extension. We also have something for Redux, also something which is very similar to NgRx data and other things as well, which aren't even here listed. So maybe interesting to check it out. Yeah, and if you want, there are some YouTube video from me about the signal store. Here you have some links as well. And I would say, yeah, that's it. Thank you very much. And we could now move on to the Q&A.
Okay, so thank you, Rainier, for your awesome presentation. And as you said, we are just jumping to the QA. So I have already the first question from the Alexander.
Yes.
So in Signal Store, if one of the methods wants to use another method defined in the same with methods, it can't unless you create another with methods below and call from there. Is there any better solution?
As far as I know, no. This is exactly the way how you could do it. Theoretically, you could, of course, also create multiple with methods. So if you say you have with methods and you want the second one to inherit those, then this is also possible. But I have to admit, it's not very nice. It doesn't look very nice.
Okay. There is like another question. Probably we should understand it like whether we should use Signal Store for each entity.
Yes, there is an extension with entities, which would actually allow you to manage multiple entities within a signal store. But the documentation also very clearly says, this is an exception. You should try to have one signal store per entity, if this was the question.
Okay.
And
yeah, do you want to
Mateusz, I mean, I think we can also mention that you are the top contributor to the signal store, so you can also join the discussion. I am sure you also have an opinion.
Yeah, but your answer was like perfectly correct, and I would say like nothing to add there. So yeah, as you said. There is another question from Edwin, whether we can access data from global store signal store within the features signal store.
Yes, of course. So you can just inject the store instance from the global store. It's just an inject store that you have to do, but you can also use multiple feature stores together as well, because the quiz store is just another service, and another store could also just inject the quiz store and use that one as well. So that's not a problem.
Okay. Another question from Adam. In your example, if I only patch the title in the quiz store, then will only the title signal fire, or all of signals originating from the quiz store then?
No, only the title. This is proven. There are a lot of unit tests which exactly cover that part, that only the title fires and not the others.
Mm-hmm. What's patch state? Is it similar to computed?
No, patch state would be similar to signal set and signal update. But the main difference is that patch state says you don't need to provide me the complete value of the signal, only those properties you want to change. Because this is exactly what we have, where when we have demand for the signal store, that we say we have a lot of properties in our signal, and we don't want to clone it all the time. We only want to change this or that other property. And this is why we have the need for a patching function. Okay. It's not computed.
Another question from Marcus. Does the store create signals for properties in the objects? How's about performance?
How does the store create signals for properties in the objects? I guess this is about the deep slice, the slices. Mm-hmm. Yeah, so they are first of all created on demand. There is a proxy which runs internally. So if you never require it, for example, if you never require the slice of title, it's never created, this kind of signal. But internally, you of course, you have a normal signal for that. And well, I don't think that there is any performance penalty you have to pay. It's like you have computed for a subproperty.
Yeah. You have mentioned about the testing, so we already have a question like, what's the best resource for learning the test signal store?
There is an open GitHub issue where Mateusz and myself have been assigned to. We have to write the documentation. Yeah, so it's not there yet.
Yeah, I was even thinking about this issue when I just was preparing to this meetup that, okay, you will be there
Yes.
with this issue and what's going on, whether it's already started. Yeah, so you guys motivated us to.
Yes, exactly. There is also something else. There is this open issue where another colleague presented this provide the mock signal store function, where we are still, I think it's still an open discussion how we are going to do it, especially how the mocking works of the signal store. Do we want to bind ourselves to a certain library like Sinon.js or Jasmine, or do we provide some generic methods? And I think that's crucial for the testing documentation as well, because you might not only want to test the signal store itself, but you very often have use cases where I say, I want to test a component which uses the signal store, and I want to mock the component. So, and this is what this discussion is all about.
That's right. So another question, when do you prefer to use signal store?
To be honest, at the moment, I mean, it's still in developer preview, but it's very stable. I have to say I prefer it always. So I think there are some very rare edge cases where you might want to use the Redux pattern for a very complicated state. There, I would say it would make sense to go with the global store, but only for those selected use cases if you really need it. In terms of the component store, it's clear the signal store is the successor. This has been said at NgConf already. And in general, when do I use state management? Well, I would say start with a signal. And when you see your signal grows in size, then you could do this intermediate step with the signal state, which I haven't shown, or just go straight to the signal store. I generally, when I have a signal which is large enough, I always go directly to the signal store, because you have seen it's just a one-liner. You say signal store with state, and that's it. You automatically get patch state and the slices for free. And when you then start adding features after feature, then you can make use of with methods and with computed.
Yeah, and also we can create these custom features as well. Yeah, so we can like decouple our code, reuse it, and it can be global as well. It's just a matter of injection, whether it's in the or the particularly. Okay, there is another question. I have store which uses 5 feature store. Can I override some methods declared in that feature store?
I have a store which uses a feature store. Well, if you have a signal store feature like the with countdown, then you can override it. There is currently a PR which discusses this behavior, maybe that we don't want to override it or that we want to have a protection for overriding. As far as I know, it's still in discussion. And I mean, if you have an existing signals, an instance of a signal store, I don't think you want to override it. So.
Yeah, we had this concern to just share with you guys when we have been like thinking whether to migrate to the signal store, and we have been looking for some weak sides of the signal store. So it was like you can create these features when you hide some kind of the logic, and then you put it in your store. And below this feature, you will create like another with methods, which misleading or by accident will just create the method with exactly same name, and this method will be override. Yeah, and right now you will not be notified that you are overriding the method which already exists in your signal store or something like that. Yeah, so that's the one thing we have to be cautious when we work with the signal store.
Exactly. The other thing, maybe if we already talk about the maybe not so good things, is encapsulation. That always comes up very, very often, that people say, well, what does it mean? Can I now update my signal store from everywhere, from every component? At the moment, yes, you can do this. And here I think there is something which is going to change in the signal store version 18, that we will get some concept of encapsulation.
Okay, and maybe the last question. What if I want to use signal store for shared entities, master data? Should we provide the store globally?
Yes.
Yeah. Okay, so Rainier, that was the last question. We want to extend our heartfelt thanks for you for the fact that you find the time for us. And also we are looking forward to the possibility of having you as a speaker again, or see you somewhere in live on some conferences, what will happen for sure in the future. So thank you one more time.
Thank you very much, Mateusz, and I think we will see each other in Belgrade.
Yeah, so have a nice evening.
Bye. Thanks for listening. Goodbye.
Okay, guys, so that was the last talk we have prepared for you today. And before I let you go, I would like to remind you about our survey, which will be visible soon on the chat. Please fill it out, provide us with the feedback, and help us to make the future event even better. Also, there will be a link to the spaces where we can perform some networking, talk about your impressions, discuss all the questions which maybe we haven't been able to answer, and so on. So that will be the great time to be there, that you can talk each other. I saw that you had great discussions here on the chat. You can continue on the Google Meet. And I also want to remind you that our next event is on the 21st May, online and in Warsaw, exactly same hour, 6 p.m. You will have a chance to listen to 3 awesome talks. First by Aristides von Bakos about the new Angular version and what's new in Angular 18, durable and modular front-end application with NX by Luca Del Pupo, and the Angular query by Krzysztof Skorupka. And at the end, I have to ask you to remember to subscribe to our social media, Angular.love, where you can find us on Facebook, Twitter, YouTube, LinkedIn, and meetup.com, so you wouldn't miss interesting Angular content, blog posts, and of course, our next event in May. So that's all from our side. Thank you for being with us today. It was really great. We just break our record of the active people. So thank you one more time and have a nice evening. Bye.